No. As you can see, the precipitate for these three metal cations, the copper, iron 2 and iron 3, they are all insoluble, right? Reason being, copper, iron 2 and iron 3, they are all basic hydroxide. They are not amphoteric, right? They are transition metal and they are all basic hydroxide, right? Meaning they do not react with excess base, right? So unlike aluminum, lead and zinc that are amphoteric hydroxides, the copper, iron and iron 3, they are basic hydroxides, so they will not react with excess base. So the blue precipitating copper would remain blue in excess sodium hydroxide. The green precipitating iron 2 would remain green in excess sodium hydroxide. The red-brown precipitating iron 3 would remain insoluble in excess sodium hydroxide, right? And then you can take this from the board and I'll write the equations to show these reactions. With these four additional cations, you can see that based on the color that is formed, blue, green, red, brown, we would not really need to do the test with ammonium to distinguish between them. Alright? However, if you should, the exam still required to know the test with ammonium hydroxide and copper, iron 2 and iron 3. Alright? So let me just tell you what will be formed and if the precipitate is soluble, yes or no. Good? And then we're going to move on to identifying gases and then identifying the anions last. I want to do the gases before, because what happens is that when we're identifying the anions, sometimes it's heated to see which gas is formed. Alright, you get what I'm saying? So it's more important to do the gases before the anions. Alright? So dropwise ammonium hydroxide and excess. Alright? So as in previous case, it's a blue. Copper is always blue precipitate, iron 2 is green precipitate, iron 3 is red brown. Alright? But in this case, copper 2 is soluble precipitate while iron is insoluble. So let's note that in excess, precipitate soluble, meaning the blue solid here will disappear if you add excess ammonia to the copper. Alright? While the iron in both cases would be insoluble.
So it will be colorless.
No, you will just go back to blue solution. Because in truth and in fact, a copper 2 plus solution is blue. You're looking at it. It's not like it's a colorless solution. Right? So sometimes, even if you get this stuff in the exam, if you don't get the solution is blue, you add the sodium hydroxide here from a blue precipitate. But the solution itself in the first place was already blue. Alright? Precipitate insoluble. Alright? Right, so remember that with ammonium hydroxide for the copper, iron 2 plus, iron 3 plus, the copper precipitate is soluble, but the iron 2 and iron 3 is insoluble. Right? So let us move on to identifying gases next. Right? Gases that we need to be identify at this level: hydrogen, oxygen, hydrogen. Carbon dioxide, hydrogen chloride. Alright, you want me to let me write them here and then put the name next to it. Carbon dioxide, hydrogen chloride. HCl gas. So this is not sulfuric acid, it's hydrogen chloride gas, right? Also need ammonia gas and chlorine gas. sulfur dioxide, nitrogen dioxide, water vapor. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright? So those 9 gases we should be able to identify and to explain why. Alright? So these 3 gases, right? Colorless. Got we got oxygen and hydrogen in the air, right? Colorless, odorless. So we cannot see, we cannot smell. Oxygen, hydrogen, and carbon dioxide, right? But the hydrogen chloride gas is colorless. But it have a sharp acid odor. Alright, so based on just looking and smelling at these 4 gases, we can see that we could actually tell which is hydrogen chloride. Because hydrogen chloride actually have a little acidic smelling odor. You know, like the taste would be like you drink orange juice is acidic. Yeah. That's how they would inhale it, it would smell like some acid smell. Alright, so the test, so these are the properties. Right? And the test right. So, say for example, we have a matches, right? And we should out it. You see, if you expose it to a glass container with pure oxygen, it will just relight. Alright? Or even if you don't relight, it actually see the flame or the heat gets brighter. Right? That's typical for oxygen. Alright? It supports combustion. So anything that is burning and you put oxygen there, it will actually burn more. Alright? So the test for this in the lab, say we have a match, we light it, we out it, and then this is the test tube with oxygen gas and we put it, it will just relight. Right? So in the air, remember that you have mainly nitrogen, like 17, probably 79, 78% nitrogen and just 20% oxygen, right? So that is why if you should out a match in the air, you probably don't have enough oxygen circulating to relight it. But if you should put it in a pure container with oxygen gas, it actually relight, right? Because just remember that oxygen supports combustion, right? For hydrogen, you'll hear a squeaky pop. So these things I can research them on YouTube, you actually hear it, right?
Tingnan ko walis kung ano yung class ay may natapos combustion.
Alright, good. So it make a squeaky pop and a lighted spin. So when exposed, right? Reason being, it reacts rapidly with oxygen in the air. Alright? So if you have the energy there and expose the hydrogen, it will just react rapidly to cause a pop in sun. And that is actually hydrogen reacting with oxygen to produce water. Alright? That's a reaction that is actually taking there. And actually water vapor, to be more specific, right? We got oxygen, hydrogen, carbon dioxide. In terms of the properties, they're all colorless and odorless, right? So no, you cannot see them, you cannot smell them. They are just there inert in the air, right? But for the oxygen, it will relight a glowing splint, while hydrogen will cause a squeaky pop when exposed to a lighted splint, alright? And that is because it will provide energy that hydrogen needs to react with oxygen in the air to produce water vapor, alright? Well, carbon dioxide, the reaction for carbon dioxide is what we call calcium hydroxide solution, right? We will call it lime water, right? You should probably get this in biology as well, right? White precipitate with what we call lime. But just to know that this lime water is calcium hydroxide, alright? Alright? So they form a white precipitate, right? While hydrogen chloride will form white fumes when exposed to ammonium chloride, right? So the HCl is ammonium or ammonia gas. Right, so take these from the board and then I'll write the equations which support the relighting the glowing splint, the squeaky pop, the white precipitate with lime water, and the white fumes that is formed. That's explanation of this that we just showed. So for the relight glowing splint, oxygen supports combustion. Alright, so it's actually one of the reactants to burn in material is the oxygen. Right? So for the squeaky pop is hydrogen gas plus O2 gas to produce H2O gas. It's an explosive reaction, right?
I say water vapor.
Yeah, that's why the water at this form is water vapor, right? So for carbon dioxide, as I said before, it actually formed the white precipitate with calcium hydroxide. So it is calcium OH2 AQ plus CO2 gas alright, to produce calcium carbonate plus water, alright? So this is the white. Alright. So the balance. If we continue to bubble the carbon dioxide in the solution, this precipitate can actually dissolve to form the hydrogen carbonate. Alright? We continue to bubble the carbon dioxide gas. Alright, it can actually dissolve the calcium carbonate. So dissolve the calcium carbonate plus H2O liquid plus CO2 gas produce calcium. There's hydrogen carbonate which is soluble, AQ. Right? So if we continue to bubble the carbon dioxide gas that we're testing with the precipitating from the calcium hydroxide, it will actually dissolve to form the calcium hydrogen carbonate. Alright? So sometimes the book may require you to identify the further explanation. But most often than not, they just want the white precipitate with lime water. And remember that lime water is calcium hydroxide solution. Alright? While
the excess, that is the excess at the time.
While this here is the hydrogen chloride gas, is HCl gas plus NH3 gas to produce ammonium chloride solid.
Ammonium always solid, yes.